Yay, it's working. Okay, we're finishing up the notes here. Example 7. It says, for each of the following, find kind of a key there. It says, without graphing. Find the period, the range, and then the domain exclamation point. Nice. Excitement built right into the lesson. Okay, this makes a great multiple choice question, okay, on your test when? Wednesday. Now, on the multiple choice, I don't care. You're not going to have a calculator. I don't care if you graph it to answer the questions. It's going to be a little bit more time consuming if you do that. So what this question is about, and it leads up to the domain, can you find the domain without graphing it, which is going to require you to really understand the features of each graph pretty well, okay? And so that's what we're going to go over. First things first, though, you want to put it in a standard transformation form because tangent, cotangent, secant, and cotangent have discontinuities. They all have vertical asymptotes. And it's really about finding where the vertical asymptotes are and how often they occur for domain. And the horizontal asymptotes, or vertical asymptotes, sorry, are affected by horizontal shifts. So we need to have it in standard transformation form. So let's do that. The 3 is in the front. That's good. It's a tangent function. On the inside, if you want to do it in baby steps, go ahead and put the x term first. X term first, but that's not quite it. You can get your b value pretty easily just by looking at that, but the phase shift is going to be off. So go ahead then, before you take care of the negative b value, put it in a standard transformation form, which for us is going to involve factoring out a negative 7 pi from each term on the inside. So make sure you have an extra set of parentheses. Now hopefully the first term is going to be easy, right? When you factor something out, you're dividing out, right? Dividing out. So what is negative 7 pi that we started with divided by the negative 7 pi we factored out? 1. So we're left with 1x or just x. That's why it works. Now this is where this goes over some people's head. When I factor a negative 7 pi out of a 6, what am I left with here? It's not that hard. Yeah, 6 over what? 6 over negative 7 pi. You're dividing out a negative 7 pi from a 6. So it's 6 over negative 7 pi. And of course it is going to be then a negative term. It's that easy. Now, you quickly check by mentally redistributing. What's negative 7 pi times x? Negative 7 pi x. Pat yourself on the back. Keep going. Plus, negative 7 pi times negative 6 over 7 pi. Negative times negative is positive. Your 7 pi is divided out. You're left with 6. Great. Looks good. Okay, so now we're ready to answer the questions. Part I says the period. The period. So I'm going to call it P, and I need to remember the formula. This is a tangent. So tangent, just like cotangent, start with a period of what? Pi or 2 pi? Pi. Tangent and cotangent are the only two that have default periods of pi. They repeat themselves twice as you go around the unit circle. The only two. So we start with pi, and we divide it by b or the absolute value of b? Absolute value of b. So that's going to be positive 7 pi. If you simplify, you get 1/7. By the way, let me back up just a second. Just in the case like this is a graphing one, let's just kind of review this as well. If you ever have a negative b, you don't want to graph it with a negative b, because the negative b can always be absorbed into the a or just gotten rid of, depending if the function is even or odd. Is tangent even or odd? It's odd. So for odd functions, the negative b value can actually come out front and change the sign of a. Since we currently have a positive 3 out front, it now becomes negative 3. And then we're just left with regular 7 pi, x minus 6 over 7 pi. So we always take care of a b by bringing it out front if it's odd, which will change the sign. If we had started with a negative, now it's positive. And that would be for the odd functions. Which functions are odd? Tangent, of course. What are the other 3? Sine, cosecant, cotangent. So really the easier way to remember is there's only 2 even functions where the negative would just go away, and that's cosine and secant. It's reciprocal. Okay, good. So that was just a little mathematical aside. All right. No, and that's why it's important to put it into standard transformation first before you take care of the b. If you got rid of this negative right here before you put it in a standard transformation form, you would have the wrong value of 6. Okay? The negative has to be factored out from both. So that's why you put it in the standard transformation form first, then take care of the b. All right, part II asks us for the range. So the function's name is f, so r subscript f colon. I will be grading your notation on Monday, so make sure you have it spot on. All right, so let's see. The range of tangent with one arm tied behind your back and both eyes closed should be what? All real numbers all day long, right? All real numbers. Tangent and cotangent, remember, are the only two that have ranges of all real numbers. All the others are bounded. So that was an easy one. And then part I, is the domain. So that's a fun one. So D sub f is going to be the set of all x such that x ain't equal to, bless you, the vertical asymptotes. And so now we have a little bit of work to do. We need to figure out where the vertical asymptotes are. And then once we have one vertical asymptote, remember, we can then just say all of them are going to be however far apart they are away, plus that first one. So let's think about where the first vertical asymptote is for tangent without a horizontal shift. Tangent, unshifted, horizontally, starts off with a what on the y-axis? An inflection value or vertical asymptote? Inflection value. Good. So the very first critical value of tangent is the vertical asymptote, right? So I need to find that. Now, how far apart are your critical values for a tangent or cotangent graph? Every critical value is what fraction of the period away from each other? Half. Good. Remember, we count by half cycles. So, if the first vertical asymptote is at the first critical value, and critical values are a half cycle away from each other, if my cycle length is a seventh period, what is half of a seventh? A 14th. Good. To take a half of a number, you multiply by half, you multiply straight across. So the vertical asymptote for the unshifted tangent would be at 1/14. That's your first positive critical value. But it doesn't stay at 1/14, does it? Because now we have shifted the entire graph. What? This funky number. Left or right? Right. By this funky number, 6/7 pi. And so my vertical asymptote at 1/14 now moved to the right 6/7 pi units. So how do I find out where the new value is? Do I add or subtract that number if I'm moving to the right? Add. Good. So 6/7 pi. This then is not a pretty number. It's a rational number plus an irrational number, and I don't expect you to simplify that. That's going to be the form that it's going to be on the test, and that's the form you would leave on your quiz. This is your new vertical asymptote on the graph, and you haven't even sketched it. So now that we have our vertical asymptote in hand, now I just need to say plus how often they occur, and they will occur at regular intervals. So now we think about tangent again. Your vertical asymptotes are how far apart from each other in terms of the period? A fourth? No. Well, the full cycle, right? Pi is generally the full cycle. But for tangent and cotangent, vertical asymptotes always occur one cycle away. Because remember, that is going to be the full period between any two vertical asymptotes. We count by a half cycle. So vertical asymptote, a half cycle, another half makes a full cycle. All right? So what is the period for this graph? 1/7. So how far apart are the vertical asymptotes from each other? 1/7. So we'll just say plus 1/7, which is the period, times n, where n is a integer. And that takes into account full multiples of n, both positive and negative. And that would be your answer. It's not pretty, but it is what it is. I would never give you ugly numbers like this if I expected you to graph it. They're either going to both be rational or both have pi in it. In this case, I can choose ugly numbers because you're not trying to set up an x-axis. You're just listing stuff. Okay, now that will work each and every time for a tangent graph. So let's summarize. The domain for any tangent function is going to be the set of all x such that x is not equal to your first vertical asymptote is always going to be at the first critical value, which is at what fraction of the period? 1/2 the period. So it's going to be 1/2 the period plus Your C value, remember C from the standard transformation form is your horizontal shift. And that number could be plus or minus. Yeah? If you're moving to the right, it's going to be plus. If you're scooting to the left, you're just going to subtract the C value. And that gives you your new vertical asymptote. And then plus how often they occur, which for tangent is what? The period times n, where n is this integer. And there you go. For those of you who like to memorize formulas, because you have a very large hard drive over your shoulders, you could stick that in there. But you don't really need to memorize that. And I would prefer that you actually found it by understanding how tangent works. Okay? But that'll work every time. All right, questions on letter A. All right, I'm going to give you 2 minutes to do part B on your own. See how far you get. You will find that cotangent perhaps is just a smidgen easier than tangent. All right, go. 2 minutes, and then we'll see how far you got, and we'll do it together. This is where you're doing it at home on video. Any other worksheets from yesterday? If you happen to not be here yesterday, then all we did is 17, 18, 19, and 20 from the worksheet. When you turn in your worksheet on Monday, just make sure that those 4 questions are spot on perfect, because I will grade those separately for accuracy. Thank you. Oh, okay. I'll take that too. I'll grade those 4 questions from your worksheet separately for accuracy, not for completion, and that will count as a quiz grade. And then the rest of your worksheet, I'll grade as always as a completion grade. So you don't have to come in out of school and make up what we did yesterday. What's that? No, it was supposed to be due at the end of class yesterday, unless you didn't finish, and then I said to do it for homework. But if you misunderstood, that's fine. Just turn it in with your worksheet.
I said the last one would be right.
That's fine. Yeah, that's fine. No big deal. I want you to know how to do all that stuff by the time the test comes around. So if you haven't finished it yet, you just have math homework over the weekend, which is one of the lucky ones. Makes for a great weekend. I think you'll notice a little deja vu with some of the numbers on this one. All right, that was 2 minutes, but I was talking over y'all, so I'll give you all another minute. The domain is the big one. The other 2 are pretty easy. I would ask you a domain question on the test. Multiple choice. No calculator. %90 chance of rain today. Looks like I've got lucky with the other 10% so far. Corona, is it raining out that window? No. Okay. So, 2 windows out of which it's not raining so far. It's a good start. Maybe it's raining outside the other 18 windows. Math joke. Okay. Number sense got that. I'm good. I'm glad. Good practice for tomorrow. Yeah, how many of you are going tomorrow to the cafeteria at Clemens? Yeah, okay, just 2 y'all. 6. You know what time the bus leaves? You got permission? I need yours still.
I turned in.
Did I give you one though? Can you still turn it in to me? Because I want a hard copy. Yeah, just bring it tomorrow morning. It's fine. I don't want. Yeah, just for my own records. I want to see your mom's signature. I hear it's pretty nice. Okay, yeah, thank you. All right, So I put it in standard transformation form. It's the same C value. Let's talk about how to get rid of the negative B value for this particular one if we were to graph it. Is cotangent even, odd, or neither? Odd. So the negative goes away or comes out front? Comes out front. So again, it's not always just going to be negative. It's going to change the sign of whatever A happens to be. A happens to be a positive 3, so now it's a negative 3. But had we started with a negative A, bringing the negative up front would make it a positive, okay? It just changes the sign. But that's not real critical for what we're doing. All right, so letter I, or if you want to start calling that letter the square root of negative 1, that would be acceptable. We want to find the period. So the period is pi over the absolute value of B. So it's pi over 7 pi, which I do want you to simplify on the quiz. It's a 7. Okay, same thing. Part II, or I squared, which is also known as 1, right? I squared is negative 1, sorry, not 1. Good catch. We're trying to find the range. So the range of F is what? All real numbers. If you want to fancy it up, you can say it's the set of all y such that y is an element of the real numbers. That'll work. Or if you want to say negative infinity to infinity, because it's fun to draw lemniscates. That's what the infinity symbol is called. I get it. Or you can just put the double bar R. That works too. All right, so let me shrinky-dink this down. So I have room for the exclamation point, which is I, or I cubed. And, of course, I cubed is the same as what? Negative I. You learned your powers of I in Algebra 2? I squared is negative 1, so I cubed is negative I. And I to the 4th is 1, and then it repeats. Okay, good. Just another math review inside a math problem. So meta. All right, so let's go ahead and start. It's the domain that is the set of all x's such that x ain't vertical asymptote plus the shift plus multiples of how often they occur. Now, cotangent, without any horizontal shift, on the y-axis has a what? A vertical asymptote or an inflection value? Vertical asymptote. Ooh, okay, so that's easy. So I don't need to go over a half cycle to get to my first critical value. I just can say it's 0 plus now any phase shift or horizontal shift. We don't call it phase shift here, but we shifted right 6 over 7 pi. So once again, we're going to be adding 6 over 7 pi. Oh, yeah, it also works if you do 1/7, because that's 1 cycle over. Now, I'm glad you brought that up, Kate. On the test, it's going to be a multiple choice question. I would not put 1/7. I am always going to put the first non-negative vertical asymptote where it went, okay? That would have actually have been, well, I mean, that works, but I'm not going to do that. Yeah, so it would be either 0 or the first positive one. I'm not going to use a negative one. So I prefer 0 there, but of course, if this were an open-ended question, a quiz or a free response, I would accept 1/7 as well. Okay, cool. So this is my new vertical asymptote. And now all I have to do is say plus how often they occur. And once again, tangent and cotangent have vertical asymptotes every what fraction of the period? Every 1 full cycle of the period. Every cycle. So plus 1/7 n, where n is an integer. Now, if this were a multiple choice question, because it's 0, I wouldn't even put it there. I would just have 6 over 7 pi plus 1/7 n, where n is an integer. So it consolidates a little bit more nicely. All right, so let's go ahead and write kind of a summary for this one, for you formula memorizers. In general, the domain of any cotangent function is going to be the set of all x's such that x ain't equal to 0, so just the c value, good, plus pn, nice, where n is, of course, an integer. You could just put the c value. Yeah, I only put the 0 plus just, for illustration, that we are still going to the vertical asymptote, and it just so happens that 0 plus c is just c. Okay? And remember, c could be positive or negative. You have to, if you're shifting to the right, you're adding. If you're shifting to the left, you're subtracting. So it's going to be the opposite of what it appears. It looks like a minus sign in the equation, so you're really adding to your C value, with your C value. Okay, so that takes care of tangent and or cotangent. You'll have one like that on your quiz on Monday. You'll sketch one of tangent, cotangent, you'll sketch one secant, cosecant, and then you'll have one of these 4 types. I think I'm only going to give you one of the 4. So now we're going into the other 2 types, the secant, cosecant, and we're starting with letter C, which is cosecant. So we'll do C together, and I'll give you a couple minutes to then do D on your own. Some of you all have already started without me, and I apologize for being so slow. All right, step 1, standard transformation form, yeah. So we have a -4 cosecant, and notice the x term is already listed first. That's great. So I'm going to factor out 4 pi sevenths, and I'm going to leave that then as x plus or minus something, and then the plus 6 goes at the back. So this one is a little bit more fun than the previous one. I am factoring out a 4 pi sevenths from a -11. So recall that factoring out is the same as dividing out. So what I'm really doing is I'm doing 11, or -11 really, divided by 4 pi sevenths. But dividing by a fraction is the same as multiplying by the reciprocal. So really it's going to be -11 times 7 over 4 pi. And then you multiply straight across. What's 11 times 7? 77, and the denominator is 4 pi. Okay, and there it is. Now, if you want to do it off to the side, that's a gross C, yeah. -11 divided by 4 pi sevenths. And in honor of National Puppy Day yesterday, stay, good puppy, good puppy. Change, flip. Okay, so you do that, and then you multiply straight across, and you get -77 over 4 pi. Social media was lit up yesterday with all kinds of cute little puppies. Today is International Achievers Day. You think it's going to be lit up with pictures of everybody's international achievers? Here's a picture of my favorite international achiever. No, I doubt it. I doubt it. Who is your favorite international achiever? Do you have one? Or are you your own favorite international achiever? That's probably good. All right, be your own hero. Good advice. All right, we got into standard transformation form. We've had a little extracurricular dialogue also to try and focus again. Math requires a lot of focus, concentration, and by me deliberately distracting you, it's me training you. Okay, me training you. So let's go to part I, and that was the period. So the period for secant, cosecant starts with what? Pi or 2 pi or 7? 2 pi. Good. Remember, this comes from sine. So it's 2 pi over the absolute value of b. Our b is already positive, so no big deal. Stay, change, flip. We get 2 pi times 7 over 4 pi. You can put your 2 pi over 1 if you want. And now divide out. Your pi's divide out. And then your 2/4 becomes a half, and you're left with 7 halves. Or 3.5. I'll keep it as 7 halves. Stay, change, flip. Divide out, simplify, boom, 7 halves. So I do want you to simplify on the quiz tomorrow. So that's the length of one cycle. All right, part II, the range. This function's name is Lil G. Lil G. Good album, yeah. Lil G, the cosecant sessions. All right, straight out of cosine. That would be the secant sessions. Okay. Is it all real numbers? I'm guessing. That would be an answer choice. No. Is it no real numbers? No, it actually exists, so it's not no real numbers. So remember that cosecant came from sine, and we spent a lot of time finding the range of sine. Sine is bounded above and below by the amplitude, right? And so if you want to think about it in terms of sine, go to your standard transformation form. Our sinusoidal axis for sine was at 6. Our low point then, we went down 4. 6 minus 4 is 2. So the low point was 2. The high point was 6 plus 4, which was 10. So sine oscillated between 2 and 10, 2 and 10, 2 and 10, and 2 and 10, and 2 and 10, and so on and so forth. So if sine is between 2 and 10, cosecant is going to be everything outside 2 and 10. So to write everything outside 2 and 10, it's going to be negative infinity up to 2 with a what? A parenthesis or a bracket? Bracket. Now I'm going to use the beefiest of all brackets, the beefy brown bracket. Union, beefy brown bracket 10 to infinity. So pretty easy if you understand how sine and cosecant are related, which you should. And then the fun one, part I. The domain of G. It's going to be the set of all x's such that x ain't equal to. Trying to find the vertical asymptote, shift it over the c value, and then how often they occur. Cosecant then came from sine. Let's think about sine. Sine is sahala. So it starts on the y-axis at an axis, then goes high axis, low axis, high. Remember the vertical asymptotes from cosecant came from flipping which critical values? The axis, the highs, or the lows? Axis. Good. So anytime sine has an axis, cosecant is going to have a vertical asymptote. So where is the first vertical asymptote for cosecant? At 0. Sine starts at 0 on an axis, so cosecant starts much like cotangent at 0 with the vertical asymptote. So again, for illustration purposes, I'll put 0, although it's not required, plus, now I need the shift. This one shifted over what? Left or right? 77 over 4 pi. Right. So I need to add or subtract it. Add it. 77 over 4 pi. Congratulations. You now have your first non-negative vertical asymptote. And all you have left to do is say plus how often they occur times n. Well, don't take that for granted. How often, in terms of the period, do the vertical asymptotes of secant and cosecant occur? For tangent, it was every full period. Well, in terms of the period. Is it every half period? Is it every fourth period? Is it every 3/4 period? Is it every full period? Every half period, okay? Every half period. Because remember, you have to have 2 vertical asymptotes per cycle. Because you have one branch going up and then a vertical asymptote, and another branch going down and another vertical asymptote. So it takes 2 vertical asymptotes to make one cycle. And since we count by quarter cycle intervals, your vertical asymptotes are always 2 critical values away, whether it's tangent or cotangent or secant or cosecant. Your vertical asymptotes are always 2 critical values away. So if we're counting by quarter cycles, 1 quarter plus another quarter is a half. Okay? So for secant and cosecant, your vertical asymptotes are always at a half the period. If the period is 7 halves, what's half of 7 halves? Half of 7 halves. To take half of a number, you just multiply it by half. And you just multiply straight across. So you get what? 7/4. Right. So to take half of a fraction, you either double the denominator or you take half the numerator. But we don't want to call that 3.5 halves because that's mixed notation. But if your numerator had been an even number, you could take half by taking half the numerator. So 7/4 n, where of course n is what type of number? An integer. That should be pretty easy. Okay, so there you go. Now, of course, I'm just going to modify this one. Because we started at 0, you wouldn't even have to write 0. And that cleans it up a little bit better. So let's summarize then. For the domain of any cosecant graph, it's going to be the set of all x such that x ain't 0, which we don't need, plus c, so it's just the c value, plus, and then it's how often they occur, which we said was what fraction of the period? Half, so 1/2 p n, where n is an integer. So very similar to cotangent. The only difference is it's a half period between vertical asymptotes instead of a full period. Sweet, 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 sweet. All right, we got we still got plenty of time. Questions before I cut you loose on secant? If you had to vote on your preference, do you like the tangent questions better than the cosecant questions? Yeah? Yeah. That's not surprising because we spent more time doing sine and cosine, and really cosecant is just that flipped. Okay, so that was a very informal, unnecessary survey with very little ramifications based on the results. All right, 2 minutes. Go ahead and answer parts 1, 2, and 3 for letter D. I'll give you a rain update. Still not raining out this window. Croner, can you help me? How about the other window?
Nope.
Still not raining out two windows. They dropped 20% from 90, so now they're only 70. They dropped down to 20% from 90%. That's weird. Last night before I went to bed, 90%. This morning when I get up, 20%. How that's a huge margin of error if you're a meteorologist. They use mathematical models to predict, but I don't know. Yeah, 78132 to 78130. Yeah. I mean, if it's not raining out this window, it could very well be raining out that window. Just one window away. I can imagine a whole zip code away, or area code away, or state away, or world away. I wonder if it's raining right now in Uranus. I'm sorry. Y'all drew the short straw to have me as a teacher. I apologize. Yeah, and Tate, you lost the dad lottery, I guess. All right, I'm trying to catch up with y'all. Y'all keep working. Pay no attention to me. Bless you. So again, the first two are just kind of like to pad the average. They're kind of gimmies. I'm expecting you, bless you, to get those right. Everyone should get those right. The period, 2 pi over b, right? So it's 2 pi over 1 times the reciprocal, 7 over 4 pi. So you can set it up like that, or however you want to do it. You end up with the same answer, 7/2. So what I'm trying to do from one to the next is really focus on not the change in the phase shifts or the change in the period, but rather what's the same and what's different regarding where the vertical asymptotes are. That's why I use the same numbers. All right, the range. Well, same thing. 6 minus 4 is 2. 6 plus 4 is 10, so it's outside of that. So negative infinity to 10, union 2 to infinity. Is that right? That would probably be an answer choice. I think that would be a great answer choice. That is totally wrong, right? Increasing order. I got my 10 and my 2 backwards. Sometimes I make mistakes on purpose. Most of the times, no. All right, there you go. I do. That would be a great answer choice as well, wouldn't it? And it would still be the wrong one. I do need brackets. Excellent. That would be an answer choice. And I'm trying to think about another answer choice. Y'all can appreciate the humor in this one, though, right? Hey, where you at? I'm at infinity. You don't need to say the word at. Okay. You can't go to infinity. It's an endless destination. Good. Okay. Can you rope the moon? Probably more likely than reaching infinity, right? Yeah. A lot of people write songs about trying to rope the moon. The domain. Set of all x such that x ain't what? Yeah, where is it? Is that 7/8, 7/2, 0? Let's think about it. Secant, or in this case, negative secant, doesn't really matter, as you'll see, comes from a cosine or a negative cosine. Cosine starts at a high point. Negative cosine starts at a low point. But it doesn't matter if it's plus or minus because the very next critical value is an axis point. It's the second critical value, or I'm sorry, the first critical value that is the axis point. Very much like tangent. Very good. So that's going to be our vertical asymptote. So how far away is the first critical value for a secant or a cosecant graph? we count by quarter cycles, okay? Tangent's a half cycle, but we're counting by quarter cycles here. So if the period is 7/2, what is a quarter or a fourth of 7/2? 7/8. Good. So 7/8 is where the vertical asymptote is without a shift, pre-shift. Now we have to apply the shift. Plus if we're moving to the right, minus if we're moving to the left. Once again, we're moving to the right, so it's plus 77 over 4 pi. There is your new vertical asymptote. And now all we have to do is add multiples of how far apart they are. And we've already established this. For a secant or a cosecant graph, the vertical asymptotes are what fraction of the period away? Half. So now half of 7/2 is 7/4 times n, where n is a integer. And again, that would be the multiple choice answer on the test. That on the quiz Monday is what you're going to write. You don't simplify the numbers. You just leave it like that. You walk away. So now in general, for a secant graph, the domain of any secant function should be the set of all x such that x is not equal to the first vertical asymptote is at what fraction of the period? A fourth. So 1/4 of whatever p is, plus your phase shift, c, and then plus multiples of what fraction of the period? A half. Excellent. So 1/2 the period n, where n is an integer. So again, the summary formulas are nice to have because it does tidy up our conclusions that we gain from the numerical evidence up above. But it's not necessarily something that you want to memorize. I'd rather you just understand how the graphs are created and where things are. But I'm not going to stop you from memorizing them and using them. I can't. Right? Just like I can't stop you from thinking about goldfish. What color was yours? Orange, probably? When you were thinking about it? Was it this class that I mentioned about goldfish? Or was it last class? Whoa! Something exciting happened. Goldfish have very short-term memories, and so do I. So do I. I can't remember if I told y'all already. Did I tell y'all? No. So just like a goldfish, I can't remember. Goldfish supposedly have very short-term memories, which is why you have to be in charge of feeding them. Because they'll eat. They're like, I'm hungry. Oh, there's food. I'll eat. I'm full. Hey, I'm hungry again. They just forgot they're full, and they'll go eat again. And they're like, I'm full. Oh, I forgot that I'm full. I'm hungry. And they'll keep eating, and they'll die. So that's why you have to regulate their food. Now, that's important for goldfish care, but there's an easy market in the goldfish community for a goldfish comedian. A goldfish comedian only needs one joke. It's beautiful. Because you can tell that same joke over and over again, and because goldfish have very short-term memories, they'll laugh every time as if they never heard it. Yeah. So, anyway, think about it as a career choice. It could be any joke. It could be any joke. As long as it's funny. Goldfish are pretty particular when it comes to humor. They won't laugh at anything. But if you can find one joke that they'll laugh at, you can reuse that joke every 5 seconds. But, oh, that's a good one. Oh, that's a good one. Hey, I'm hungry. Okay? So, anyway. We're essentially done. Are there any questions at all about this section or about what's due Monday or what I'm going to have y'all do in class on Monday? Quiz. Let's go ahead and just officially say that there'll be 4 questions on the quiz because I'm not going to be here. If I give you a lengthier quiz, you pretty much have most of the class to do it. I'll do one of each of these, okay? I'll do one domain for a tangent cotangent and one domain for a secant cosecant. And as you might anticipate, maybe I'll give you one of them that starts at 0 and the other one I'll make you move it over so that you understand both ideas. And then you'll have one question like we did in class yesterday from 17, 18, 19, 20 in the worksheet where you're actually going to sketch a transformation of a secant or cosecant, and it'll be an easy shift. It will not be ugly numbers like we have here, 7/8 plus something with pi. It'll be nice numbers. You might have to make new numbers, though. And then you'll have one with tangent and cotangent, and each time you'll be writing an equation in terms of the cofunction. All right, so 4 questions, but lots of points. And I'll grade those myself as if it were like a test, okay? So we won't have you grade them. I'll grade them as if they were a test, and I'll give those back to you. I'll give those back to you, I guess, Tuesday. We'll go over those, talk about the test. Test when? Wednesday. Croner, is it raining out that window?
No.
No. It's not raining out this window either. And you know how I could tell? If it were raining out this window, that fresh dog poop there would be wet. And on that note, we'll end. That's how you can tell the weather where there's dogs. Yeah. That's a variation on the wet rock weather station, right? You put a rock outside. When the rock is wet, it's raining. When the rock is dry, it's not raining. When the rock is red, see, I don't know what that means. It means you got a red rock, I guess. Yeah. Hey, have a great